All right, let's try this again. I have an excellent connection, so I am connected, but I have no actual signal. Whoa, all right. There we go. All right, we're up and running. Cool. So what I wanted to do this week for weekly stream of engineering and AI work was DeepSeek has been making a lot of headlines lately. Meanwhile, OpenAI and ChatGPT have gotten more restrictive. I've been running into paywalls as I try to use the free version of ChatGPT. If I'm trying to generate images, after 3 images, it's kind of done. And I think you get, for the most part, like 3 requests per minute. So it's becoming harder to use it as a digital assistant because you have to get into those paywalls. So even for myself, I wanted to kind of document like how to get DeepSeek up and running with this Ollama software. So first step is download. I'm on Linux, and when I do this, I was running into some problems with curl. So let's do zoom in. So it tells you to do a curl and then just run that sh command. Oh, no, it did work. All right, so it seems to work. Up and running. And while it's doing that, we could take a look at what this install script is actually doing. So it's running this bin, like a shell script, checking what kind of Linux there is. Anything else? Where are we grabbing? Checking for NVIDIA, so looking at hardware, local hardware stuff. Install complete. Give you install command, some outputs there. Let's see. Oh, Windows subsystem for Linux. So you can use the same process for Windows subsystem for Linux, and then even run that NVIDIA pass-through to see if you have GPU. I don't think I have GPU like dependent, like anything that's worth definitely connecting. And DeepSeek, one of the things that it's supposed to do is do pretty well without GPU acceleration, but anyway. Okay, cool. So now I have Ollama installed, and pretty easy, just kind of running there. Get rid of that one, don't need it. Send that. Let's minimize that. And we can go into like the models and see DeepSeek R1. I'm gonna grab this 1 GB version of DeepSeek R1 just because it's a little smaller. And the command to run it is this, but first we need to actually like download it. So how did we do that? Models. Let's go back to the GitHub page because I think it's run, create, run, pull. So we use like a pull command to grab what models we want. I'm just going to clear this. So instead of trying to run it, we're going to say pull, pulling that manifest, and it'll take a few seconds, start downloading, and it's grabbing DeepSeek-R1 1.5 billion parameter model. The more parameters we use, the bigger. So in these models, so the more parameters you use, the harder it will be to run on the computer. So now we can try this serve command just to see, right? Oh, run command, sorry. Run command, there we go. And now I have DeepSeek running in my terminal. So let's check it out. What kind of model, large language model, am I running? Then it tells you that it's thinking. And then I'm DeepSeek R1 AI assistant, Chinese company DeepSeek. Do my best to help you. So let's give it like a engineering problem. Oh, you know what we were just taking a look at today? Go into, we're just kind of talking about this week. Was looking at some Newtonian. I was wondering what would happen here if I tell it that I wanted to consider thrust, gravity, drag, and wind, and rather than tell it to draw a free body diagram, I'm going to tell it to give me an equation of motion that considers those things. So we should end up with two equations of motion. I want you to take on the role of aerospace engineer and give me the equations of motion for let's see how that one works. So it's thinking. So I'm telling it that there's thrust, gravity, drag, and wind, and treat it as a point mass. So I want the equations of motion here. So DeepSeek is kind of interesting because it has like this thinking process where it's using a next word generation thing. Then it separates the thinking from the actual output. So it gives you all of this almost as like a kind of give you some of the process behind where the final result is coming from. And it seems to be working. Like we're running this model and we're getting some outputs. So dx and it's moving and moving. Okay, cool. So while it's thinking about that, the other thing that I wanted was it's cool to have like a terminal version, and I love running stuff in my terminal on Linux, but sometimes it's nice to have that like ChatGPT interface. So if you want to do that, we can come down here. So there's a bunch of information about Ollama and running. And DeepSeek is one of many models. So these are open models in the sense that you have access to the actual parameters that are in there, but it's not an open model in the sense, like you don't know what data was used to train these models. But you can go in there and change them around. There's the Llama models, from Meta, and all these other ones, Gemma, Google DeepMind. Lava is that one's for like visual stuff, like if you want to understand what's in an image. So here's like vision. Lava and Llama 3.2 Vision, those are ones that you could use if you want to give it an image and tell it to interpret the image. But let's get what we want is this OpenWebUI. So OpenWebUI, once we click this link, it brings us to another GitHub site. And we can see that this OpenWebUI is now a user interface for lots of different, and it's similar to that OpenAI interface, but now up in the upper left corner, we can choose what kind of model we want to use. And we can use Ollama, and there's a whole bunch of stuff. So let's see, how do we install? we're going to say pip install OpenWebUI, and then we serve that OpenWebUI. All right, so how did we do here? Vertical motion, we have AY is thrust minus gravity. Interesting, all right, no drag included. I would have expected something, right? And then this one is thrust, dx, drag and wind. So in this one, it's considering drag and wind as the same force, as if it's like pointing in the same direction. It's not really how I would do things, but we could probably play around with it and get it to the point that we want. But I'm gonna close this out, Control D, stops that one. And here, I'm gonna make conda create. I'll make a new Python environment. And in general, I use, or actually, let's do this. Clear, so we clear that out. So conda create name OpenWebUI. So I'll create a new environment for conda, and I'm going to install this OpenWebUI in that environment, and I'll use this Python 3.12. I like conda for managing my environments. You can also use like Python env ways of doing that, but conda, I've been using it for a while now, and I've just gotten used to the way that it works. So I'll install all that stuff, moving and moving. Cool. And now I can say conda activate OpenWebUI. Cool. And then let's pip install this one. Pip install OpenWebUI. Downloading, kind of running through stuff. Working and working. And since what this is going to do is it's going to serve a website on my own computer, and I've actually been able to run this on a different server and then connect that port so that now I can run OpenWebUI DeepSeek on a server that probably has bigger resources, and then open up that port so I can look at the website that's being served. But that's not what we're doing here. We're just going to run it locally right on our own computer. And it's thinking, it's kind of building stuff. Working. Colbert, AO signal, NEIO. It's getting there. And anything else we need to run here? And then there's some other stuff that we can do here. I guess if we want to connect this one, I had done kind of a hacked way rather than using a Docker command. What I had done was like just run this serve command and then SSH port forward. But this would be interesting to try out, see if the Docker can actually host it to a given website, like at least if we have a website there. And loading, it's thinking about it. There's a lot of stuff to do, right? Oh, so it's putting Docker on there, HTTP, OpenSearch. Yeah, so a whole bunch of, does it have a list of what we need in there? As I'm run compose, toml. All right, so here's our dependencies. Flask, Pydantic, Fast API, anything big, OpenAI. transformers, Python PPTX, so something to like look at PowerPoint, input output, OpenCV, probably to look at images, it's an image viewing stuff, YouTube transcript, probably grabbing YouTube stuff. Looks like it supports 3.11, 3.12. Anything else? Here's our make file. Oh, a Docker compose file. So it is all kind of running in some kind of Docker container. All right, cool. Are we all done? Yeah, cool. And then I think, what was it? OpenWebUI, was it serve? Yep, OpenWebUI serve. Serve. Let's see how it goes. Cool. So it's telling me that it's up and running here. So right now it doesn't look like much happened. It's just saying like open web UI, but now I can go to 000 8080 and now I have this and trying to remember if I entered a password here or not. Okay, cool. And some stuff about like what's new and all the cool stuff. We can execute code in real time. Wow. That sounds cool. Okay, let's go. And I'm running my DeepSeek R1, 1.5 billion. I also, as I was doing this, I have some other things that I had loaded in there as I was playing around. Here's like Coder and Llama and Lava. But let's stick to our R1. And let's do that same prompt that we were just kind of working on. I need you to act as to take on the role of aerospace engineer and create the equations of motion for a rocket lifting off from the ground, acted on by a variety of forces, including and I don't want to ask it to draw because it doesn't actually draw pictures. So now instead of a command line, so before the thinking was actually like outputting that text, now it's kind of in this drop down menu, so I can watch it do this next word prediction as I'm doing that. Or I can just hide this and say like, all right, I know it's thinking, let's see, oh, and code interpreter. Huh. Let's see. Thrust propels it forward. So it seemed, I wonder if it's getting closer to what we were hoping for. So keeps like going back, but wait, not entirely sure about this. If wind is from above, why would wind come from above? I would think wind is either left or right, kind of in the x direction. So x is saying, so it's saying thrust is along x, but also the gravity. So I guess, oh, I see. All right, formalizing. Maybe I'm getting ahead of it. Man, all right. It's really thinking through. And thinking, this is something that kind of bothers me in general about AI models is we keep using these anthropomorphizing words like thinking and hallucination, but really it's processing. It's just taking these words that I created, turning that into this vector, then doing a bunch of transformations to that vector, and then using these words to continuously predict so based on the words that it's generated so far, keep trying to predict the next words. So how are we doing so far? fx, thrust x, gx, dx, and wx. Okay, so that makes sense. Gravity along x is 0. Drag, opposite of velocity. It seems like we're getting a little closer. I wonder if I had better prompt engineering this round. So we're saying z is the upward axis, our altitude. And x is our kind of left-right motion. It's really going through a lot of thinking, going through a lot of like processing here in this like thinking step. All right, come on. Let's get there. All right, yeah. There we go. Thrust in the y. But I thought we just said y was 0. MAY was 0. Actually, while we're doing this, we might as well take the same. Let's take this same prompt and send it over to OpenAI, right? ChatGPT. So we'll take this, and it should run a little bit faster because this one has some bigger. So let's see what the two outputs are. So t minus dz, and what's this x? So horizontal and vertical. and then splitting this into like some kind of angle, where theta doesn't really say what theta is, right? Or did it? Is the rocket's tilt angle from vertical. So if theta is 0, then there's no x component. Okay. So what do we got here? Shouldn't the A... So this is assuming the rocket is a sphere, because the A in both directions is the same. Vx and Vz over V. Oh, okay. Over total velocity magnitude. Nice. So we have force of wind is pushing it to the right. So if this, so we'll say theta equals 0, and create a function integrated to find the height and x position of the rocket as a function of time. So if the rocket is pointed straight up, try that. And how are we doing over here? And we're still thinking here. So now it's plugging in some values. Why is gravity 9,800 meters per second squared? It's a lot of gravity. Cool. Now it gives us like a rocket equation, and let's see if we got so drag what about the wind force? FW, what is that one? Force of the wind. So it's just a force of wind. I would think that it's like this. I would think that this is the force of the wind, but. And then return that Vx and Vz. Cool. Show me the full simulation example. So it'll use that solve IVP. Let's come back up here and hide the thinking part. Gave us a lot of output about the thinking. And then the result is just to say that A equals F over M. Interesting. All right, well, okay. What are the sum of the F net values? And meanwhile over here, Oh, I thought we were running stuff, but we could try copying it, right? I'm gonna activate my other just Jupyter Lab. Close this one, get Jupyter up and running, and let's just come into some documents, personal, some ChatGPT stuff, or wait, wait, where did I put this stuff? AI Playground, there we go. Let's make a new Python kernel. So we ran that. We should have, so we have X values. We should have like Z values. And let's see what these plots give us. There we go, rocket path. So initially take off at 0 distance and 0 height. And based on the force, it's pushing us to the right. So our vertical velocity goes up and then changes, and then horizontal kind of hits a steady state pretty quickly. Kind of cool. What kind of forces we got here? Force of the wind is 100 newtons, gravity, density of air, cross-sectional area, meter squared, drag coefficient 0.5, and a constant thrust. And we're using like a burn rate. Is that affecting? Where does that one come in? So M0. So we are subtracting how much mass we're burning somehow. M0 minus m dot times t, or m0 times 0.1. But then how are we getting the constant thrust? That's what I want to know, because this one is not a function of that mass. But I mean, it's a start, right? We did consider that mass is changing, so it's still like a nice rocket science kind of rename. Rocket simulation. So that's kind of cool. We got there pretty quickly. And now DeepSeek shows us a little more of that like thought process. And now it's telling us more of that, like the vertical. Why would wind have a Y component? That's the part that I'm still a little confused about. Why would thrust be fighting the wind? Yeah, vertical or horizontal. I mean, unless you're taking off in a hurricane or some kind of tornado, I would think most of the time it's horizontal. And even in those cases, probably for the most part horizontal. Coefficient 1/2 CD A V squared. There should be a rho term in there, right? But maybe CD is. It doesn't really tell us what that is, does it? missing a little bit. And I'm using the 1.5 billion model just so it thinks a little quicker. The thinking process is quicker. And it's keeping wind separate from drag. And then no drag in the vertical acceleration. I mean, all right. Okay, now put those two equations of motion in a Python function. Integrate with solve IVP. So although we're not quite getting the same like speed to a solution that we're getting here, nice part is this this is all running on my own computer, so I'm not sharing. Although I'm using like this DeepSeek model, I'm not sending any of my data to the DeepSeek company. It's using their model to like run and kind of do some prompt engineering on these model outputs. And we're still getting like some of the same interface benefits as we do in the ChatGPT interface, but now we get to choose what model we actually want in here. And then there's other things that we can change in here. We can change seed, stop, temperature. This one, I always thought this was funny that temperature is the name for like introducing randomness, almost like it's an entropy kind of process, entropy driven process. So if you increase the temperature, then you'll get like and it tells us right here. Increasing temperature makes the model answer more creatively. So you can decrease the temperature so it always chooses the most likely word to come next, and then it'll be more repeatable. The results will be more repeatable. We can look at like context length, like how much, and then batch sizes, tokens keep on context, number of max tokens. Okay, so this one lets the model go back longer to generate results. And how many are preserved, batch size. A higher batch size increases performance, but it also requires more memory. So, I mean, I don't know. Let's try doubling. See how that goes. We can download as a PDF or plain text. It's still like processing what I had told it to do. Didn't like that one. But anyway, we did get DeepSeek R1 up and running on our own computer. Oh, now it's thinking. And process was relatively easy. It's more involved than going to a website and having pre-packaged something up and running. And then it does take longer to run things on your own computer than it does on giant server farms. But everything's protected. You have control over both how the model is going to react to you and what data is going and where the data is going, because it's all staying on your own computer. We got this OpenWebUI installed through pip. We served it after running, once it was installed, we served it from, again, the same Python environment. So next time I log in, I'll have to make sure that I go into that OpenWebUI environment to actually run it again. And we have all these other models that we can play around with. We can do like lava models, embedding. Those I haven't played around with, but because for the most part I was trying to see how DeepSeek and then this like Meta's models would play around with stuff. But up and running, pretty cool. And still thinking. I'll let this thing keep processing. But anyway, hopefully this was helpful for like if you're trying to get your own thing up and running, or if you want to like dump it, if you have like a server where you can run your own and try this out for yourself and then log into your own server. A nice way to like get things a little more private, have a little more control over what we're doing, which is really, that's what open source is all about. That's what I love about GitHub and all these other kind of things. It takes a little bit of extra work because you do have to figure out like, all right, how do I install it? How do I run it? Where is it? When it is running, where is it running? All that stuff. But we're good to go. Running things, getting equations of motion in here. So we're doing some engineering work with our DeepSeek R1 1.5 billion parameters. Cool. All right. Thanks a lot, and I'll catch you next time. We'll do some more engineering work. Maybe we'll keep playing around with DeepSeek, or maybe even check out what is it? Microsoft Copilot is the latest. Another similar interface to ChatGPT. Yeah, I'll skip that for now. Similar interface, but now maybe we could ask it to generate a free body diagram for us. Ooh, excuse me. Let's just do a quick So it's creating something, whether or not it's what we want. Oh yeah, it is something. Are we considering a point mass? We have a whole bunch of arrows, we have thrusts doing all sorts of stuff. Oh man, air resistance, what is this? Draw the free body diagram as a point with arrows in a cartoon format. Let's try a little extra prompt engineering. Actually, can we get that out of ChatGPT? So it's generating our image. What do we end up with here? Oh man, that is not right. VB, VF, what is this? I don't know what's going on. A K delta? All right, let's see how we did with OpenAI. Oh boy, yep. Also pretty crazy. Thust and Doid. I don't know. MG is way over here, and it has an extra drag is like an arrow pointing at it. I don't know what's going on. Jeez. All right, so there's still a lot of work to be done for generating images, I guess. it did make a nice, it made a rocket, a cartoon rocket, and over here we did get a cartoon rocket. I don't know why our space person is strapped to the side of the rocket. Not a great day, but we'll keep working on it, and things will change so quickly with this like generative AI race that's been going on. But yeah, some really weird. I don't know what's going on here. Same thing here. What is this? What are all these arrows doing? Where are they going? Why are they all pointing in different directions? Okay, all right. So that's all I had for today. And how are we doing on our? This one's still just plugging along. Oh boy. It's trying to like create some kind of integral. Yeah, we'll let it keep plugging. All right, thanks a lot. And part of this is for me, like keeping track of how I install all this stuff and put it down into memory, and figure it'll help somebody somewhere along the way.